Eneos Sustina, a revolutionary engine oil providing exceptional sludge protection and long-lasting fuel economy. The function of engine oil. When the engine is off, oil settles to the bottom and collects in the oil pan. When the engine starts, the pump draws oil up from the pan through the oil filter to the oil galley. A number of oil passes route the oil from the galley to the engine components. Oil supplied to the cylinder forms a lubricating film that allows the piston and rings to move freely. There is also added space between the piston and cylinder wall to allow free movement of the piston. The oil fills the space and provides a seal for the high-pressure combustion process to prevent pressure leakage. The engine block is cooled by coolant or antifreeze, while the internal moving parts are cooled by oil. The oil keeps the engine clean by capturing soot and dirt produced by the combustion process. Detergents in the oil grab and suspend the contaminants in the oil while helping to break them down into smaller particles, preventing sludge buildup. As the oil ages and contaminants increase, sludge may begin to build up in the piston ring grooves. If the ring loses its ability to move freely, it can no longer seal, resulting in pressure leakage. Sludge can also build up on the piston under crown and skirt, which makes it difficult for the oil to reach the piston, affecting the oil's ability to cool and carry away heat. Oil neutralizes acids that are produced during the combustion process, providing corrosion protection to metal parts. Protecting the engine from corrosion caused by sludge, keeping the engine clean, is the most important function of engine oil. Sustina provides the engine with exceptional sludge protection, ensuring a long-lasting fuel-saving effect. Let's look at how engine oils are made. Engine oils are a blend of base oil and additives. So the quality of the base oil and additives directly affect the engine oil's performance. Sustina is made with W-Base, a revolutionary high-performance synthetic base oil and additives developed with Eneos' proprietary Zinc P technology. Now let us introduce you to the revolutionary W-Base and Zinc P technologies. W-Base provides up to 2% improvement in fuel savings. In this fuel consumption test, Sustina and other existing fuel-saving engine oils of the same weight were tested in a subcompact car and a mid-size passenger car. Fuel consumption was measured using temperature and humidity-controlled dynamometer test stands. The results showed that compared to the other fuel-saving oils, Sustina provided up to 2% improvement in fuel savings. In higher temperatures, the oil's viscosity decreases or gets thinner. In lower temperatures, the oil's viscosity increases or gets thicker. The degree of viscosity change due to temperature change is called the oil's viscosity index. The higher the viscosity index, the smaller the viscosity change with temperature changes. Let's look at W-Base viscosity at -5 degrees Celsius and 80 degrees Celsius. As you can see, the change in viscosity for W-Base between -5 degrees Celsius and 80 degrees Celsius is minimal. This means W-Base has a high viscosity index. Let's see how the oil's viscosity index affects fuel consumption. As the temperature rises, the oil's viscosity decreases, making the oil thinner. It is important for the oils to provide the viscosity required to protect the engine at the maximum internal temperature. However, since typical operating temperatures are lower than the maximum, the oil can have too much viscosity at typical operating temperatures, causing internal drag and reduced fuel economy. The key to reaching improved fuel efficiency is to reduce this extra viscosity that leads to drag. However, simply reducing the viscosity would compromise the oil's ability to protect the engine from damage at extreme high temperatures. To make the oil's viscosity stable from lowest to highest temperatures is the key to achieving optimal performance and fuel efficiency. The high viscosity index of W-Base enables Sustina to increase fuel economy without compromising protection. Although Sustina with W base may look the same as conventional oils, the molecular structure is quite different. Typical base oils have a complex molecular structure built from carbon formed in a ring-like structure. At low temperatures, the molecules cannot move past each other easily, resulting in increased viscosity and poor fluidity. The molecular structure of W base is different from that of typical base oils. Instead of the ring-like carbon form, the hydrocarbon molecules in W base are aligned in a straight line, enabling them to move more freely. The W base hydrocarbon molecules move more easily at low temperatures, providing outstanding low-temperature fluidity. Let's compare the fluidity for conventional synthetic and W base oils at 0 degrees Celsius. Now compare the same three at 25 degrees Celsius. At both temperatures, the balls fall more smoothly for W base, providing low resistance to flow. W base provides less resistance to flow for easier engine starting and running, making it possible for Sustina to offer up to 2% improvement in fuel savings. Sustina's